In the previous video, we have cloned down an Umbraco cloud project and we have arranged its source code. In this video, we'll focus on configuring load balancing with Umbraco. The main steps involve setting up the web server roles in the program file based on the environment name. In this case, for the development environment, we'll use a role called single. For the live environment, we split the roles. The subscriber represents the front end of the Umbraco project, and the scheduled publisher represents the back office. Next, we'll configure a few app settings keys for the environments. For development, we don't need to set up anything special, but for the front end and back office, there are few required settings we'll need to define. I won't go too deep into the explanations for each step here, but you're more than welcome to check out the Umbraco documentation or explore the load balancing and Azure training course to learn more. So let's get started. I will start by heading to where I have my project cloned, and then I will head into the web project, and then here I will open the project by double clicking on the csproj file, which will automatically open in Visual Studio. Then I will add the necessary app settings keys, starting with the subscriber JSON file, where under the Umbraco CMS, I will add the necessary app setting key called examine. And here we are setting the Lucene directory factory to temp file system directory factory. Moving on to the production app setting JSON file, I will add two new keys called global, where we are setting the main DOM log to file system main DOM log, and a new setting called examine, setting the Lucene directory factories to sync temp file system directory factory. Lastly, under the hosting setting, we are setting the local temp storage location to the environment temp. Moving on, I will create a new class at the root of the project called Umbraco Builder Extensions with the following code and the following namespace. This is related to an SQL statement that we will add in the future steps, and it allows session data to be stored in an SQL Server database rather than in memory. Moving on, I will create one more class at the root of the project called MySurfaceController. And here I will add the following code. This is a control that writes session data to the database table that we are creating in the next step. I will first save everything. Then I will need to connect to the cloud database. So I will open SQL Server. And meanwhile, I will head to the Umbraco Cloud portal, and then under Configuration, Connections, I will add my IP. And then I have the connection details listed below. So I will open the SQL server. And then here I will need to connect with the details from the Umbraco Cloud portal. First we have the server name. Then we will need the login. Then the password. And then we'll need to click to options so that we can connect to the database, and that's where we'll need to add in the database name and click connect. Then let's open one of the tables from our database. Here let's add in the following script and execute it. This is creating a table to store session data across subscribers. In a production environment, you will most likely want to look at configuring a Redis cache instead. Also, please note that every time a new environment is created in the Umbraco Cloud portal on your project, you will need to manually create this table as well, so that your project can actually work. Now we can close the SQL server as we are not going to use it at the moment. And then in our project, I will add the new folder called server role accessors. Here's where we are going to add some server role accessor classes, which are used to explicitly define the server roles. This way, it reduces the complexity of the server election process. For this approach, our subscribers will not attempt to run the automatic server role election process or task scheduling, and will always be spun up as subscribers. So I will start by creating the first server role accessor for the schedule publisher. So I will add the new class with the following code. Then I will add one more class for the single server role accessor. And the last one for the subscriber server role accessor. Then we will need to install some packages, where in this case I will use the NuGet package manager. And here I will look for the Umbraco storage providers. First, I will install the Umbraco storage providers.azure blob. And in this case, I will need to make sure that it's on the latest Umbraco version 15, as this is the Umbraco version that I'm using as well. So the reason why I'm installing this package is because it centralizes media file storage in Azure Blob Storage, so all servers have consistent access. And I will install the Umbraco storage provider's Azure Blob image sharp as well. This one ensures on-the-fly image processing works with blob storage, avoiding issues with local caching. Moving on, we will need to register the 3 server roles into the program file, so that they are found at startup and therefore we can use them where needed. So I will replace the current content of the file with the following code. And here I will also add the missing import statement and save. Moving on, let's set up some output caching. We can do this by installing a package called Umbraco Output Caching. I will go look for it. And then I will install it on my project. This will also help in cost saving in case the website gets a lot of concurrent visitors, since without this optimization, we will need to scale up more servers horizontally when the traffic goes up. To test out that the caching works on our project, let's first create a simple document type so that we can have a template to work with. So I will start by running the project. I usually prefer the terminal of the Visual Studio, but you are more than welcome to use the green arrow to start the project. So I'll run the project with .NET Run. Then I will need to find the URL, select and right click. And then I will need to add this URL in the browser. And I will open Umbraco without restore. I will sign in with Umbraco ID. Then I will head to the settings section and I will create a new document type with template called home with the group called content and a property called body that uses the rich text editor. And then I will also make sure that I can create it at root. Then I will just refresh so that I can see my template. And here I will render my body property. And to test the output caching, I will add the following. Here we are using a .NET property that gives you the current date and time in coordinated universal time. So let's save this and then we can create some content. Let's say home and hello Umbraco, for example, and save and publish. And if you check our front end, and there we go. Now we can see the current date and time in UTC time zone. Now if we refresh this, we can see that the current date and time is currently cached. Moving on, we will need to have a Docker file, and luckily for us, we already have a Docker file already generated by the Umbraco Cloud package that we have used once we have cloned down our Umbraco Cloud project. And this is necessary for when we are going to run each subscriber in the Google Cloud Run. As a last step, we need to push our changes back to Umbraco Cloud. So I will head back to the previous command line that I have already opened, and then I will go with git status, git add, and then I will change the commit message to edit necessary steps for load balancing Umbraco, and then git push. And lastly, we also need to make sure that we are moving our content. So I will head to the back office of my project, and then I will transfer the content. So this is it for this video, where we have configured load balancing with Umbraco. See you in the next video.